So this will be given by Omkar, Dharmadhikari, a principal architect at CableLabs. So you can see we are going to hear some of the OTIC related experiments talking about testbed. They're probably the first one, if I remember, I was told by Ivan Tracy. And he's the principal architect at CableLabs, a non-profit R&D organization. Prior to joining CableLabs, he worked for Samsung, Ericsson, and a lot of 4G, 5G related projects, including Citizens, the CBRS, and others. So with that, Omkar, I'll give the floor to you. You have about 20 minutes. Okay.
Yeah, thanks. I hope you are able to hear me now properly.
Can you hear me? Yeah, we can see you. You can just present your.
We can hear you.
Can you hear me?
Yeah, I can hear you. Can you see my presentation?
Please proceed, Omkar.
Okay.
Thank you.
So hello, everyone. My name is Omkar Dharmadhikari, and I work as a principal architect in the wireless R&D group at CableLabs. And today I'm here to talk about testing and verifying Open RAN at the Kyrio OTIC. And I would like to begin by thanking the event organizers for providing me with this opportunity to speak here at this event. So let me start by providing some background on CableLabs, who we are and what we do. CableLabs is the leading innovation and R&D lab for the cable industry, headquartered in Louisville, Colorado. We are a non-for-profit organization funded by our members who are primarily cable operators. We have over 60 member companies, more than half of them being mobile operators that provide services across 5 continents and serve more than 150 million households and mobile users worldwide. Moving on to the lab infrastructure at CableLabs. So CableLabs is a premium innovation lab that is dedicated to building and orchestrating emergent technologies. The lab infrastructure is used to perform validation, research, proof of concept, standards development, and new technology assessment. The labs host advanced technologies and expertise, including advanced optics and fiber, hybrid fiber coax, mobile Wi-Fi convergence, cloud native security, wireless physical layer RF analysis, and AI and machine learning. CableLabs has a long history of hosting interoperability events for the telecommunication industry for different technologies such as DOCSIS, Wi-Fi, optical, CBRS, and SAS IoT, and TIC Community Lab for open front haul testing. Kyrio and SATE are the subsidiaries of CableLabs. Kyrio offers testing for development, interoperability, comparative analysis, and certification for various wireless and wired products. Kyrio offers the facilities and expertise required to test Wi-Fi, passive optical networking, and 4G, 5G equipment. Kyrio Lab is an authorized certification lab for devices running DOCSIS technologies and packet cable. Developed in cooperation with cable operators and cable equipment manufacturers, this premium certification lab is designed to facilitate the manufacture of interoperable cable devices, including cable modems, set-top boxes, digital TV devices, and telephone equipment. Kyrio is the first open RAN OTIC in the Americas, used for testing of interoperable RAN equipment for mobile networks to help accelerate the development and widespread deployment of open and interoperable 5G networks. Kyrio was approved as an OTIC in June of 2022. With regards to Open RAN, the CableLabs and Kyrio lab infrastructure hosts multiple test platforms that have capability to perform the conformance testing of individual subsystems with wraparound testers, along with the UE and core simulators for testing interoperability with RAN subsystems and testing an end-to-end network for performance analysis. Now, let's talk a little bit about why Open RAN. With many of our members owning both fixed and mobile assets, Open RAN is an essential work area within CableLabs, as it can be seen as a key enabler for conversions of fixed and mobile across wired and wireless networks. With the introduction of service-based architecture in 5G and more emphasis on network disaggregation and virtualization with control and user plane separation, and a cloud-native core that enables a more granular distribution of network functions operating as a combination of microservices, Open RAN has become an important part of building 5G mobile networks and has seen one of the biggest shifts in the radio access architectures over the last couple of decades. Both greenfield and brownfield deployments are pivoting towards Open RAN to realize the cost savings for future-proofing their networks and adding flexibility with a mix of vendor equipment, widening the supply chain. So talking about some of the basic building blocks of Open RAN, we have hardware-software disaggregation that deals with decoupling of hardware and software and decoupling of control and user plane to disaggregate proprietary software from the hardware. RAN applications as cloud-native functions, orchestration and automation for increased modularity, visibility into network behavior, security management, accelerating the network optimization and fault resolution. COTS-based solutions for versatility and deployment flexibility. Virtualized and distributed network architectures for flexible and scalable architectures where virtual network functions and applications are capable of working on any bare metal hardware. Open RAN ecosystem is also seeing a shift from virtualization to containerization to provide even better scalability. And open interfaces and open APIs moving away from the proprietary interfaces for accelerated innovation, vendor diversity, and competitive ecosystem, reducing barriers to entry for new entrants. What these key Open RAN drivers enable for operators is the ability to have intelligent and programmable networks, deployments with vendor diversity, and innovation agility with a faster time to market. All of which leads to the most important KPI of reduction in the total cost of ownership. And beyond the economic advantages, ORAN can be seen as an opportunity to create application-focused 5G networks that could cater to verticals and varied use cases, catering to diverse customer needs. So based on our experience across several testing efforts that we have been part of, I would like to discuss some of the key takeaways, starting with the growing pool of vendor community developing the ORAN solutions. So we have seen an uptake of ORAN-based solutions and products from the vendor community over the past few years. This has been a great testament to the industry push towards ORAN, demonstrating that ORAN is a commercially viable technology. By fostering a large, vibrant, and growing vendor community, the vision of ORAN can be realized much faster. Next is the maturity of vendor solution, key for the accelerated adoption. So creating disaggregated solutions that work well, comparable, if not better than the existing monolithic solutions, can accelerate the ORAN adoption. And the flexible and adaptive solutions needed for two plug-and-play operation. So alignment across configurations can be achieved by collaboration. Differences as allowed by the specifications call for more agile, adaptive, and implementation neutral solutions that can accommodate these implementation differences, making the solutions true plug and play. And extended range of test considerations and the role of system integrator being crucial. So to build a sophisticated software-based solution, non-established vendors or new entrants value the lag time, not just to validate the specification conformance and interoperability, but for development and re-engineering of the solutions. Some of them do not always have access to multi-million-dollar equipment, and the lag time can be leveraged by them to enhance and improve the existing solution, making it more comparable to what some of the established vendors have to offer. And the role of system integrator is very crucial. With disaggregated solutions, even though expertise at the subsystem level is important, it's not helpful to realize an end-to-end network that works. There is no value in having workable network elements without them being able to interoperate to achieve an end-to-end network needed for the service offerings by the operator. Given the magnitude and the detailed extent to which the systems need to be validated and the network needs to be fine-tuned, the system integrators with domain expertise, standards expertise, deployment experience, and network maintenance expertise are needed to build, operate, and manage the network. So now let me go over some of the key observations and insights from some of the ORAN testing efforts that have happened in our labs. One of the key observation was that the specification compliance alone does not guarantee interoperability. So the interoperating vendor solutions often comply with different specification releases and versions of a specific release. Vendors have their own spec compliance roadmap and may not be aligned with the specification version and release they comply to. And with subtle differences in IEs and messaging, achieving interoperability can get difficult. There are also differences in interpretation of the specifications, which lead to implementation differences. And sometimes the inherent flexibility allowed within the specification can also result in implementation differences. Differences in supported features can also create interoperability issues, especially the optional features supported by a specific vendor can generate optional IEs that the interoperating vendor fails to decode, generating errors. Specifications are somewhat complex, interlinked, and constantly evolving. Thus, having a clear understanding of industry specifications and vetting the specifications is strongly suggested. Another key observation is regarding the significantly varying vendor maturity within the ecosystem. So the software maturity varied with regards to the stability of the system. A software with known bugs requiring frequent restarts or workarounds cannot be considered to be a deployment-ready solution. The instability also affects the performance of the system to achieve consistently expected results while increasing the testing time in the lab as well. Another aspect is the logging capability. So solutions should have sophisticated mechanisms to log relevant data to assist with identifying and resolving of the issues. Beyond logging, the performance management counters as defined by the standards and custom set of internal counters and timers need to be made available, which are quite essential for carrier acceptance and post-launch when we talk about ORAN being part of the real-world deployments. And lastly, the flexibility and configurability, which is about having configurable parameters to easily interoperate in a multi-vendor environment. A software without any flexibility to reconfigure parameters and align with interoperating vendors will most often not thrive in a multi-vendor setting. And as we discussed earlier, the role of system integrator is essential. Instead of having siloed, distributed, and isolated expertise, limiting to integration knowledge and end-to-end view is necessary from a deployment perspective. And finally, interoperability issues are hard to get away with. Hard-coded parameter reduces the flexibility to primarily stem from custom-built solutions. And then there is hardware and software incompatibility, where certain softwares are only built to run with specific hardwares, or software upgrades cause incompatibility issues with the hardware. So what's the way forward? To wrap it up, the key aspects for the way forward to accelerate ORAN adoption, creating interoperable solutions that can truly plug and play, include having comparable solutions to monolithic architectures, enabling innovation with increased network agility and flexibility, deployment worthy cost savings. For accelerated adoption, OpenRAN must demonstrate the efficiencies that surpass the monolithic RAN it's trying to replace. Service management orchestration with multi-cloud, multi-domain, and multi-tenant environment will be a key driving force, enabling operators to manage cloud infrastructure that is including the compute capabilities, hardware accelerators, storage, gateway, and site network fabric at various locations, including the edge, the core, while maintaining the freedom to choose between the cloud providers and vendors. The SMO addresses the orchestration, management, and automation aspects of ORAN, critical for supporting and managing a multi-vendor RAN environment. And obviously, collaboration across vendors and a unified push towards the ecosystem from the ecosystem is essential to achieve the Open RAN promise. Operators must take a more holistic approach to network visibility and assurance. The mobile industry right now seems to be at a tipping point where non-traditional network suppliers are gaining momentum in developing Open RAN solutions that are slowly maturing and becoming commercially viable, reliable, and scalable to the operator community. So with that, I'll open it up for any questions you might have.
Let's thank the speaker first. So is there anything that could be useful for actual deployment? You see any, well, now it's working. So do you see, Reja, Omkar, can you hear me?
Yeah, I can hear you.
Yeah. So maybe before you couldn't hear me, the microphone was not on. My question was, do you see any specific lessons learned from these OTIC experiments to expedite the deployment?
Yeah, at a high level, I tried to cover what were some of the observations from the testing efforts, but we do have specific examples of clearly identifying the gaps in the industry, which might have some effect in terms of how quick the ORAN adoption is happening. So as part of the being an OTIC and doing all this Open RAN testing, we would be happy to share more details that could probably shed some light on that.
There is another question from the online chat. Which RAN software solution did you analyze?
I don't want to take any specific vendor names, but we have analyzed a lot of different software solutions. So as I said, we have test capabilities to analyze individual subsystems like an RU, DU, CU individually on what is the spec compliance. And then we also have simulators that could be used for an end-to-end network, where we could also test interoperability between different RAN subsystems while testing how an end-to-end network with a multi-vendor environment would look and perform.
Thank you, Omkar. So I guess with this, I would like to thank you. There will be there's some gifts will be sent back to you, but this is a certificate of appreciation for your presentation.